seminar of the subject Microcontroller and the Embedded System. I am Pratiksha from 4th Sem B section. My team members are Pranav, Pranjali, Pratiksha Shetty and Ganesh. Our topics are microprocessor versus microcontroller, introduction to ARM processor feature, embedded system, real-time operating system. My topic is microprocessor versus microcontroller. What is microprocessor? A microprocessor is a controlling unit of a microcomputer wrapped inside a small chip. It performs arithmetic logical unit operation and communication with the other devices connected with it. It is a single integrated circuit in which several functions are combined. What is microcontroller? A microcontroller is a chip optimized to control electronic device. It is stored in a single integrated circuit which is dedicated to perform a particular task and execute on one specific application. Types of microprocessor. There are four types of microprocessor. They are complex instruction set microprocessor, the application specific integrated circuit, reduced instruction set microprocessor, digital signal microprocessor. Types of microcontroller. There are five types of microcontroller. They are 8-bit microcontroller, 16-bit microcontroller, 32-bit microcontroller, embedded microcontroller, external memory microcontroller. The difference between microprocessor and the microcontroller. Microprocessor is the heart of a computer system, whereas microcontroller is the heart of an embedded system. In microprocessor, it is only processes so memory and I/O components need to be connected externally. Microcontroller has a processor along with internal memory and I/O components. Memory and I/O components had to be connected externally in the microprocessor so the circuit becomes large. Memory and I/O are already present in the microcontroller. The internal circuit is small. We can't use it in a compact system in microprocessor. Microcontroller can be used in a compact system. Cost of a microprocessor is very high. Cost of a microcontroller is very low. Due to external components, the total power consumption is high in microprocessor. Therefore, it is not ideal for the devices running on a stored power like batteries. As external components are low in microcontroller, total power consumption is less, so it can be used with the device running on a power like batteries. Most of the microprocessors do not have power saving features. Most of the microcontrollers offer power saving mode. It is mainly used in a personal computers. Microprocessors are mainly used in a personal computers, whereas microcontrollers are mainly used in washing machine and embedded system. Microprocessor has a smaller number of registers, so more operations are memory based. Microcontrollers has more registers, hence the program are easier to write. Microprocessors are based on one human model, whereas microcontrollers are based on Harvard architecture. Microprocessor is a central processing unit on a single silicon-based integrated chip. Microcontroller is a byproduct of a development of microprocessor with the CPU along with other peripherals. Microprocessor has no RAM, ROM, input-output units, timer and other peripherals on the chip. Microcontroller has a CPU along with RAM, ROM and other peripheral embedded in a single chip. Microprocessor uses an external bus to interface to RAM, ROM and other peripheral. Microcontroller uses an internal controlling bus. Microprocessor based system can be run at very high speed because of technology involved. Microcontroller based system run up to 200 megahertz or more depending on the architecture. Microprocessor used for general purpose applications that allow you to handle loads of data. Microcontroller used for application specific system. Microprocessor compile and expensive with a large number of instructions to process. Microcontroller simple and inexpensive with less number of instruction and processor. Features of microprocessor and the microcontroller. Features of microprocessor are offers built-in monitor debugging program with interrupt capability. Large amount of instruction each carrying out a different variation of the same operation. Offers parallel input or output. Instruction cycle timer. External memory interference. Features of microcontroller are processor reset, program and variable memory input and output pins, device clocking central processor, instruction cycle timers. Applications of microprocessor. The microprocessor are mainly used in devices like calculators, accounting system, gaming machine, complex industrial controllers, traffic light, control data, military applications, defense system, computation system. Applications of microcontroller. Microcontrollers are mainly used in devices like mobile phones, automobiles, CVD or DVD players, washing machine, cameras, security alarms, keyboard controllers, microwave oven, watches, and MP3 players. Conclusion. Both of these processors are good. However, which one should be used depends upon your requirement. Microcontrollers are mainly used in small applications like washing machine, cameras, security alarms, keyboard controllers, etc. Whereas microprocessor is used in personal computers, complex industrial controllers, traffic light, defense system, etc. Microprocessors are much faster than the microcontrollers. The clock speed of a microprocessor is above 1 gigahertz, while in the case of a microcontroller, the clock speed is 200 megahertz or more, depending on the architecture. Thank you.
Hi, I'm Pratiksha Shetty from B section. My topic is Introduction to ARM processor. Contents are Introduction to ARM, examples of day-to-day life embedded system where ARM processor is predominantly used, types of ARM processor. Let us know about the introduction of ARM. ARM is originally ARM RISC machines, later advanced as RISC machines. It is a family of reduced instruction set computer. British company Arm Holding develops the architecture and licenses it to the other companies who designs their own product that implements one those architectures. ARM processor can be used as 16-bit and 32-bit processor. ARM Holding primary business is selling IP cores which license users create microcontrollers, CPUs and system on chips based on those cores. ARM do not make ICs. ARM grants license of cores to different silicon vendors like ATMEL, NXP, Cirrus Logic, etc. These companies make ICs. Examples are given below. There are several generations of ARM designs. The original ARM 1 used 32-bit internal structure but had a 26-bit address space that limited it to be 64 KB main memory. The limitation was removed to ARM 3 series which has 32 bits address space and several additional generations up to ARMs remained 32 bits. Released in 2011, ARM v8 architecture added support for 64 bits address space and 64-bit architecture with its new 32-bit fixed length instruction set. ARM Ltd also released a series of additional instruction set for different rules. The thumb extensions add 16-bit 32 bits instruction for improved code density, while Jazzle added instruction for directly handling Java bytecode due to their low cost, minimal power consumption and lower heat generation than their competition's ARM processors are desirable for lightweight, portable, battery-powered devices including smartphones, tablets, laptops as well as their embedded system. These are some for examples of day-to-day life embedded system where ARM processor is predominantly used. For example, we have camera, JBL, mobile phones, tablet, washing machines and laptops. ARM processors can be divided into ARM Classic Processor, ARM Embedded Processor, ARM Application Processor. ARM Classic Processors means ARM Classic Processors includes ARM 7, ARM 9, ARM11 families. ARM 7 TDMI is still shipping 32 bits processor. ARM 7 based processors are still used in many small and simple 32-bit devices. ARM Embedded Processor, ARM Cortex-M processor are energy efficient, simple to implement and are mainly developed for advanced embedded applications. ARM Cortex are series of processor provided solutions for the real-time embedded system. They provide highly reliability, high fault tolerance and real-time response. Whereas we can also know about ARM applications processor, ARM Cortex-A of a processor are called application processors. They are highest performance processor for ARM. They are used in powerful mobile devices, compelling technology products like network devices, consumer applications, automation system, automobiles, and other embedded systems. The Cortex-A processors are again divided into high performance, high efficiency, and ultra type processors. ARM embedded processor, ARM Cortex-M processor are energy efficient, simple to implement, and are mainly developed for advanced embedded applications. ARM Cortex-R series of processor provided solutions for the real-time embedded system. They provide highly reliability, high fault tolerance, and real-time response. Whereas we can also know about ARM applications processor, ARM Cortex-A of a processor are called application processors. They are highest performance processor for ARM. They are used in powerful mobile devices, compelling technology products like network devices, consumer applications, automation system, automobiles, and other embedded systems. The Cortex-A processors are again divided into high performance, high efficiency, and ultra type processors. Thank you.
Hi, my name is Pranav. I am going to explain on the topic AMD processor future. The future of AMD processor is bright with new developments and advancement on the horizon. An exciting area of growth in the field of AI and machine learning, where ARM processors are being used to power the edge of computing devices. Another area of potential in the automotive industries, where ARM processors can be used to power self-driving cars and advanced drive assistance systems. With the increasing demand of smart and connected devices, ARM processors are used to play the crucial role in shaping the future of the technology. Increased adaptation. ARM processors are experiencing increased adaptation in various industries and use cases. In mobile device market, ARM processors have dominated for years with almost all major smartphone manufacturers using their products. Additionally, ARM processors are being used in services and data centers due to the energy efficiency and scalability. The adoption of ARM processors in these industries is expected to continue to grow with more companies recognizing the benefits they offer. Advancement in technology. ARM processors have seen significant advancement in technology in recent years, including the introduction of new features and capabilities. One notable development in the integration of AI and machine learning capabilities into ARM processors, allowing the more efficient processing and complex algorithms. Another advancement in the use of multi-core processors, which allow the faster and more efficient processing of tasks. The advancement of making ARM processors even more visible and capable of handling a wide range of applications. Challenges and opportunities. As with any technology, the increased adoption of ARM processors comes with both challenges and opportunities. One challenge is the potentially or security vulnerabilities. As more devices become connected to the internet, there are more risk of cyber attacks. However, there are also opportunities of innovation and growth, particularly in the area of IoT and edge computing. As more devices become connected and require low power processing, ARM processors are well positioned to meet these demands and drive further innovation. Conclusion. We can conclude that ARM processors have came a long way since the inception and now a critical component in many modern technologies. With new developments and achievements on both horizons, the future of ARM processors looks bright. As we continue to seek increased adoption and innovation in this field, it is the increased adoption of ARM processors comes with both challenges and opportunities. One challenge is the potentially or security vulnerabilities. As more devices become connected to the internet, there are more risk of cyber attacks. However, there are also opportunities of innovation and growth, particularly in the area of IoT and edge computing. As more devices become connected and require low power processing, ARM processors are well positioned to meet these demands and drive further innovation. Conclusion. We can conclude that ARM processors have came a long way since the inception and now a critical component in many modern technologies. With new developments and achievements on both horizons, The future of ARM processors looks bright as we continue to seek increased adoption and innovation in this field. It is clear that ARM processors will play a crucial role in shaping the future of the technology. Next, Pranjali will continue the topic of embedded system. Thank you.
Hi everyone, I'm Pranjali. My topic is embedded system. First, we want to know about what is embedded system. The embedded system is one that has a computer hardware with the software embedded in it as one of its component. That means a computer which has hardware, it also contain its software in it. It is known as the embedded system. The embedded system is also known as a processor based system that does not look like a computer. Then the embedded system has lot of examples. That means manufacturing equipments, motion sensors, and car and vehicles, medical devices, and auto visual equipments, domestic appliances. These are all the embedded systems example. Then we move on to this is the organization chart of the embedded system. The next slides we want to discuss deeply. Then we move on to classification of an embedded system. There are two types of classifications: hardware embedded systems and software embedded systems, which means the figure shows the first figure shows the hardware structure and then the software structures. Then the type of embedded system. There are mainly four types of embedded systems. Embedded system is mainly classified into two types, and then the types contains hardware and software. Then the embedded system is mainly classified into four types. They are standalone embedded systems, real-time embedded systems, network information appliances, and mobile devices. First, we move on to standalone embedded systems. Standalone embedded system, as the name implies, standalone system work in a standalone mode. The standalone system which is work under the standalone mode. That means they take inputs, process them and produce the desired output. We take a desire which we want to obtain output, and the input can be electrical signals from transducers or commands from the human being, such as pressing a button. The output can be electrical signals to drive another system, an LED display or LCD display for displaying of information to the system. Embedded system used in processor control, automobiles, and many more appliances fall into the categories. To the next type, that is real-time embedded system. The real-time embedded system in which some specific work has to be done in specific time period, called the real-time embedded system. For example, consider a system that has an open a value within 30 milliseconds when a humidity crosses a particular threshold. If the value is not within the 30 seconds or 30 milliseconds, then such systems, such strict deadlines are called real-time systems. This is the information about the real-time embedded system. Then we move on to network information appliances. This is a picture which has shown the network, how it go to the many parts. Embedded system that are provided with a network interface and accessed by networks such as Local area network or the internet are called network information appliances. Such embedded systems are connected to the network, typically a network running TCP or IP, means transmission control protocol, or internet protocol, which means the TCP and IP's full form. Petrol suits such as internet or company internet. Next we move on. It is mobile devices. The mobile devices such as mobile phones, personal digital assistants, smartphones, etc. are the special category of embedded system. Through the PDAs do many general purpose tasks. They need to be designed just like the conventional embedded systems. This is the embedded systems organization. This means the CPUs is the main part of this embedded system. The sensor, AD conversion, DA conversions and actuators are connected like a serial. Then FPGA and software memories are also have the input and output of the CPU, and sensor and actuators are directly connected by the intermediate of electrochemical backup and safety internal environment. Then we move on to features of an embedded system. These are all the features of an embedded system. In that, the embedded system do a very specific task. They cannot be programmed to do different things. Embedded system have very little limited sources, particularly a memory. Generally, they do not have secondary storage devices such as the CD-RAM or the floppy disk. And we have know about the CD-RAM or floppy disk. Embedded system have to work against some deadlines. A specific job has to be completed within the specific task. Then we move on to significance of this embedded system. Due to their compact size, low cost and simple design aspects made embedded system very popular and encroached into human lives and have become indispensable. They are found everywhere, some kitchenware to spacecrafts. To emphasize this idea, here are some illustrations are there. This is the information about the embedded system. Thank you.
Hi, I am Ganesh Kehar, here to explain about my topic. Topic is real-time operating system. Let's go with slides. Real-time operating system contents definition, type of real-time operating system, advantages and disadvantages, application, comparison between regular and real-time operating system. Firstly, we know about what is operating system. Basically, operating system is the program. It is initially loaded into the computer after the booting the program. The operating system manages all of the other application programs in a computer. What is real-time operating system? Real-time operating systems are used in environments where a large number of events. It is connected external to the computer system. It is accepted or processed in a short time or within a certain deadlines. Type of real-time operating system. Basically, a three type of real-time operating system, namely hard real-time operating system, soft real-time operating system, firm real-time operating system. Hard real-time operating system. These operating systems are do the critical tasks within a range of time. Soft real-time operating system. This operating system provides some relaxation in the limited time. Firm real-time operating system. Real-time operating system of this type have to follow deadlines as well in spite of its small impact. Missing a deadline to have unintended consequence including a reduction in the quality of the product. Example, multimedia applications. Next. Advantages and disadvantages. Advantages. Maximum consumption. It consumes more output from all the resources. Second one, task shifting. It takes to time shifting the task one to another very less. For example, in older system, it takes about 10 microseconds shifting one task to another task. The latest system, it takes only 3 microseconds to shifting one task to another task. Focus on application. Real-time operating system in embedded system, error-free. These type of system are error-free. Memory allocation. In this type of operating system, memory allocation is best. Disadvantages. Limited task. It performs limited tasks simultaneously. Use heavy system resource. This type of operating system use system resources. It causes the increase of cost. Complex algorithm. The algorithm was difficult. Device driven and interrupt signal. Threat priority. That means the switching task is very less. Minimum switching. It takes more time to switching the task. Applications: industrial control, telephone switching equipments, flight control and real-time simulations. Next we discuss about a very interesting topic, comparison between regular and real-time operating system. Regular operating system, real-time operating system. The design of regular operating system is complex compared to the real-time operating system. Regular operating system is fairness, real-time operating system is guaranteed response. In regular operating system, average bandwidth is provided. In real-time operating system, strict timing constraints are provided. The components are unknown in regular operating system. Components are known in real-time operating system. The behavior of operating system is unpredictable in regular operating system. The behavior of real-time operating system is predictable. The regular operating system is type of plug and play. Real-time operating system is upgradable. These are all my topic. Thank you.